So today we are giving a brief introduction to our club, the astronomy as itself, the journey, and then what we are going to do with astronomy and what are the stuff what we are doing in astronomy basically, and then why the telescopes and the observations and different instruments they are important in this journey. Okay, so it's a one of the oldest science in the mankind, I would say, and then it has developed through different phases. Okay, so I'll just briefly introduce these things and then the big questions we are now asking in the field of astronomy. I'll discuss about that. So first of all, a hearty welcome to our Nakshatra Astronomy Club. So this is just a new club we have developed and it has not spread so much word so far because it's just like 1 month old or so. And then also, just 1 second. Yeah. And then also not much activity have been started, but we have planned so far so many things. For example, here just giving a brief overview of our website. So far we have developed, and I guess you all went through it, probably have joined as a member. So in this particular web page, we are okay. Let me. I guess I need to change the settings. Okay. Hi Sri, are you there?
Yes, sir.
So please, if anyone wants to join, so can you please allow him or her to join when there will be a notification? Anyone?
Yes, sir. Yes, sir. All right, sir.
Okay, okay, sure.
Thank you, sir.
Okay. So this is our website we are talking about. We have just developed it, and then we are trying to put as much as content into it. So the object of interest for such kind of outreach and astronomical outreach is basically different types of solar system objects like the eclipses, lunar eclipses particularly, which are very interesting things to observe through a telescope. So we purchased an 14-inch telescope which can be utilized and used, and then all the conjunctions, transits, all nearby nebulas, which and the galaxies also. These are the different stuffs which would be interesting to look through our 14-inch telescope, and with time to time we are going to organize events, night sky observation events, depending on the types of objects which are available in the sky. Okay, so please keep an eye on this particular web page, and once you become a member, we are making it an automated process so that all the members will automatically get notifications about the upcoming events and what's going on in these club activities. Okay, so the event is basically what are going on the sky, in the sky, and in, for example, 2022, different meteor showers and different celestial events is a list which is given here, and then activities around the world that we are going to propose, so that we are going to learn, and then we are going to update these things. For example, the James Webb Space Telescope is going to be launched in next month, so almost a month from now, and it's one of the biggest and most powerful infrared telescope. So you can be a part of the telescope project in future once it gets launched, and then you can get and look at the data, what is it going to do with these things. So this is a thing. And also this astronomy, the telescope we are using on the ground, it's not just for your fun. Okay, you can actually do some research stuff. I mean, it's possible. For example, in this particular page, which is known as the research scope, we have actually listed all the discoveries which are made through these amateur telescopes in different times. So basically, this is a small list, but there are a lot of more, I mean, whole lot of bunch of astronomical discoveries which are made even with a smaller telescope, but with some dedicated interest into that field. Okay, so basically it gives an very nice enthusiasm, like, okay, with this kind of telescope we can actually use for, even we can actually participate in actual astronomical discovery in a part of the astronomy. Okay, so the members area, we have 5 groups, working groups. So you can join as a member in either of these groups, or you can be a supporting member. For example, let's say if you are interested in organizing any event during the observations, that is, you are welcome. But if you join as a group O, if you know any of the eminent lecturer or any enthusiastic person in the field of astronomy, astrophysics, or anything related, and he or she wants to give a talk on that particular topic, please let us know. Then you could be a part of that public lecture organizations group and the presentation. And also, if you are like to contribute to development and value additions, for example, adding more information to our web page, also the Facebook page, or any of those uh, social media link. So you please let us know. Then you can be a group E. And then on the day of the actual night sky observation, if you want to be a part of like crowd management or participate, you can be a part of group C, and you can also be a part of our supporting group. So basically, supporting group is basically, if we have any events or any activities going on, if we spread the words among your colleagues, among your neighbors, among the students or people around you, and then so that would be a part of the support. We don't really expect much from the supporting group, but at our support just by spreading the word that the things going on here. Okay, and also if you learn any new things from the news, medias, or anywhere, please let us know. Like, okay, this seems to be interesting, or ask us like an astronomer. So if you have any questions or doubts, we will definitely do the best we can do to answer your question. Okay, so you can join either of these 5 groups, or you can just join simply a member. Okay, so we have 4 secretaries. Sri Shuman, she is here present now. She is the chief secretary, and then Arpita, K. Srivastava, Nakshi, they are also working, and together we are trying to manage the entire programs, all the upcoming events that we are trying to do. But if you want to be actively participate, let us know. Then we can make you as a part of the team of secretaries, and we also have assistant secretary who can help you to organize the events. Uh, Professor B.S. Murthy, our director, that is a founding member of this particular telescope or this jam. I am the faculty in charge, and we have the supportive members here, so you can get all the details from here. Okay. So from time to time, we are going to upload and update everything on the Facebook and the YouTube channel. So please have a look at it. Okay. So going back here, so these are links to our Facebook page and YouTube channel, so you can actually have a look at it. And today is a very good day to start, because it's a World Science Day for Peace and Development. And then this is UNESCO have actually declared today as a such day. And then this year their theme is basically how to make our world sustainable, so that we are, as a next generation and the future generation, they can survive and sustain, they can breathe, and they can live peacefully in this world. Okay, so now we'll start. What we do in astronomy first, we are doing very simple things. So basically, if we explore, and if we learn, or if we seek the very truth of our existence, the truth of our very existence, then basically what we are doing, we call the astronomy. And basically, and there are lots of other branches in the physics, and they are leading to answering different questions. But the fundamental questions, like who are we, and where do we come from, and are there really other planets or any other spaces, any other areas in the entire universe where people or human like us really they exist. Okay, so the question like, did life ever exist on the other world, or where they are or they are still there. All these questions, they are like part of what we are the astronomical journey called. Okay. And not only that, so we have other questions. For example, now we have discovered that the Mars have the ice cap, the ice pole that is seen, you can see in the left panel here. So the natural question that in sometimes will be able to live on this planet, Mars, or for example Venus, which is shown in the right panel here. So can which also asks the same questions: can we save our Earth from being dry and burnt open like Venus? Venus is very dry place, very hot, and nothing can survive on the surface. So I will show you again another picture. But like as you know, the temperature of due to the global warming, the temperature of Earth is rising. So is it possible that one day our Earth will turn very much inhabitable like Venus? But can we stop it? All these questions are very, very relevant, but these questions also came to our mind when we look at the sky, when we look at the other planets, other solar systems, and everything else out there. For example, like our Earth, are there any similar systems? This is a surface of Mars taken with a MRO, Martian Rover Orbiter, and you can see there are rocks which are being spread all over the surface. But also, if you look at the surface of Venus, you can see it's very like a molten lava. It's very hot, and nothing can sustain there. So we always ask questions: are there planets out there which are maybe similar to Earth, or even Mars, or even like Venus? But if they exist, how different they are, or how similar they are? And finally, I mean, the basic or the fundamental question: how did everything all begin? So how did Earth and the other planets form and develop in this particular context? So basically, the big questions like how do we actually exist in this entire universe, the world around us? So, Sun, so to answer all these questions, the first thing is basically we can look the planets, the celestial objects around us, and they do hide the answers to these big and the fundamental questions. For example, here you can see the picture of sun, and here you can see there is a one solar flare, what we call the flare, which is actually a kind of eruption from the surface of the sun, and that moves towards the earth, and then it related as a solar wind. So these solar nebula, they actually preserve. These are like a giant gas clouds. Okay, so they preserve lots of information which were very billions of years old. So basically, our Earth is basically few billion years old. So which means if you look at the celestial objects which still preserve billions year old evidences, then actually you can seek the truth like how everything began. Okay, so basically sun also contribute, although it's very hot, everything is very uh, high temperature and it's burning everything. So but still the outer chromosphere, what we call the of sun, they can preserve uh, dating back to very long time. So what was there around us? So and we get to know about these things when these particular flares they are moving through the space and reach our atmosphere as a solar wind or solar storm, what we call it. Also the comets, if you look at the comets, there are sometimes we actually see comets on the sky, but these comets are looks really beautiful, but they also hide lots of information. For example, these comets are basically lumps of ice and dust particle around us, and these ice and dust particles they are very old. Okay, although um they are young, but their content is very old, which means they are hiding something very fundamental answers to these fundamental questions, which are like how did we landed here in Earth? I mean, how do we come here? Okay, so looking at the comments or the studying comments can also give clues to the answers of these basic questions. Also, other places, for example, what we call the asteroid belts. Asteroid belts are something broken pieces of asteroids and the planets which are in orbit between Mars and Jupiter. Here you can see the picture. So these asteroid belts They are planets which cannot be formed because of the strong gravitation of Jupiter. So Jupiter actually prohibits or interrupted the formations of planets uh, in this particular asteroid belt. So that's why it's broken and they are pieces. So basically, this can also give us information like what was the uh, situations, what was the conditions during the formation of our own Earth, and exactly this particular basic building blocks of planets can give a very crucial clues to the formation of our own planet Earth. Here is a picture of taken by Chandrayaan-2 telescope, and then you can see the surface of Moon, and on the surface you can see lots of craters. Okay, so these craters are basically very old. Okay, so these craters have been created during the bombardment of the meteorite on the surface of Moon, and those bombardments happened during the formation of Moon and Earth system 4.4 to 5 billion years back. Now, these particular craters, and you can see their names, Sommerfeld, Kirkwood, and all other names. This particular crater actually contains material that have been preserved all the way back like 4.5 billion years time scale. Okay, so then if you study those materials and if you can collect and study them, then you can actually answer what happened back then 4.5 billion years ago. Okay, in the Moon. But this is important because if the same meteorites also bombarded on the surface of Earth, but because of our atmosphere and all our geological process, these particular evidences have been washed off. So looking at the Moon or going to Moon, collecting these samples actually gives us a very important evidence or the answers to the questions how the Moon and Sun or the planetary system formed back to billions of years ago. Also, there is a very important evidence. For example, here in this picture, you can see there is a rock sample. This is a meteorite rock, which is called the Murchison meteorite. This is landed in Australia in around 1980. And this one very interesting thing about this meteorite, when the scientists collect that and then they did analysis, lab analysis, they found this particular piece of meteorite contains amino acid, alphatic hydrocarbon, aromatic hydrocarbon, fullerene. All these are basic building blocks of life. Okay, particularly the amino acids. So basically, this particular analysis, the meteorite which comes from nowhere and we don't know from where it comes, and then it landed on Earth, then it contains all the basic building blocks, which means that it may be possible like few billion years back, similar meteorite hit the Earth, and then it brings all the amino acids and all the fundamental things that we need to actually develop life on Earth. So if that is true, like we are all aliens and we are here like coming from some meteorites or some other things. Okay, so this is still like this discovery is real, but we cannot really say like we are coming from or we have evolved from such kind of amino acid and things, but it is a possibility. Okay, so that's why our very existence, to seek the truth of our very existence, we need to look at the materials which are out there in the space. Like here is in one example of the meteorites. But we also, it's not always possible for us to go there always and see and check everything. So we also develop different techniques. For example, if there is a radar technique, which actually can send very long signals, and then we can actually try to map the surface of different planets and different celestial objects. For example, this is a picture of Mercury, and then by sending the radar wave, scientists they have bounded that radar wave out of from the surface of the Mercury, and then they found the evidence that Mercury contains a molten core inside. Okay. Not only that, actually, the Cassini-Huygens, this is a new satellite missions to actually probe the Saturn rings and the structure of Saturn. Before this mission was launched, actually, there are lots of this radar technique have been used to find out, okay, the Titan, which is like a moon of Saturn, one of the moon of Saturn, there might have some lakes of liquids and fluids. So we already know that long before using radar. but then the Cassini-Huygens after they confirmed such things. So, so these techniques have been developed a long time back, and then we are using them to find out the initial details of the about the planets, and that gives us further motivation to make it special, to make like invest lots of money to go and see what's out there, to make satellites a spacecraft and then move it, send it back out there to Saturn or Jupiter. But all of above, so we started all this journey, all these questions can be answered, and people have tried over time using telescopes. So here is a couple of telescopes called the Keck telescope. It's a 1 10-meter class telescope, and they are actually radically changing. It's in Caltech. They are radically changing the our perspective towards the universe or towards the sky. Okay, so they are constantly making discoveries, and then they actually help us to understand how the universe of the sky is behaving or moving. Okay, so that's why this brings us an important understanding, like why we actually need telescopes, why we need instruments, and then how they can shape it. But then the question, like all everything, we have to look at the sky. So why you want to look at the sky? As I told you, astronomy is a human adventure. So if you have even if you don't look at the sky, you are always been landed here from some asteroids, some meteors, and then you might have evolved from there. So okay, your very existence is the astronomy, even if you don't want to look at the sky. And then it's all been started from the dawn of the civilizations, and people have developed so far. And then also astronomy is revolutionary science and technology that shapes our modern life. And finally, it's really cool to actually look at the sky using a telescope if you do so. Okay. Now, how does this particular uh, stream in astronomy or the history have been developed? How it has been contributed by astronomer over time? So we'll just briefly go through different astronomical uh, sites. For example, Pythagoras. So it's long back, 500 years before Christ. He was a Greek philosopher, and then he believed that circles and spheres, they were perfect. They are the heavenly form, and we are the human beings. We are on the earth, so earth must be very spherical. Okay, so that was his belief, and and Pythagoras also believed that earth is at the center of the universe. Okay, but that is what we found from the ancient scripts and the books written and taken by Pythagoras. It's a long back. But then Aristotle, he was a very big philosopher in 300 BC. He described that evidence for a spherical earth. Okay, so the ideal orthodox belief was the earth was a flat, but he first time uh, put some logic into that. Okay, earth is actually spherical, not the flat, and then the evidences he put forward, like okay, we can here you can see the ships which is sailing towards the horizon, it gradually disappears. So if earth is studied, should not see that. Also, the lunar eclipse always showed a curved shadow. So the curvature actually tells you it must be it might not be a flat or spherical. And then the altitude of the North Star changes as we travel to the north, which means that Earth's surface is flat, it should not change because it's curved, so it changes as you move along. Then Ptolemy, in 140 AD, he actually first created the geocentric model of Earth, which means Earth was at the center of all the motion. Everything moved around the Earth in a circular orbit, and this model was accepted by the Catholic Church until the Renaissance. Okay, so this is the ideal initial belief that Earth is center of everything. Okay, it's called the geocentric model of the Earth. Later, Hypatia, we just one request. So if you have any questions, you can write on the message box. So at the end of the talk, I'll come and answer your questions, and we can also have a discussion. Okay, during that time. Hypatia was a natural philosopher from Egypt. She wrote many books on astronomy, and she first time introduced the idea of the conic section, which leads to basically the hyperbola, parabola, and ellipse. So he basically introduced the concept of symbols in learning science, mathematics, and technology, and then that is shown here. As you know, like how can you know different shapes of the parabola, hyperbola, and the other conic section, which was very important then. Then there are two honorable mentions also in India. We have Aryabhatta, which you all know about. But actually, Aryabhatta, probably you may know, like he invented zero and the number system. But apart from that, he had very important discovery back then, like 500 AD. Okay, so almost 1,500 years back. He actually find out correctly that Earth rotates about its axis. Okay, so he was the first who actually proposed that rotation of Earth around its axis and apparent motion of stars in a relative motion caused by the rotation of Earth. So basically, he first proposed that the stars are moving in the sky not because the stars are moving, the sky is moving. It's basically the other way around. The Earth is moving. Aryabhatta described a geocentric model of the solar system in which sun or moon are each carried by the epicycles. They turn and revolve around the Earth, okay, which is said. And the solar and lunar eclipses were scientifically first time give the scientific explanation of the eclipses. He says it's not Rahu and Ketu, which we believe here. He says it's basically shadows of moons and the other planets, moon and the sun, which actually causing the eclipses. Okay? So he first time explained the eclipses in terms of shadow cast by the and falling on the Earth. Okay. So these are the major astronomical contributions by Aryabhatta, and he is also a mathematician. So he had several contributions towards our mathematical and astronomical development. But these are three I found is the most important by him. Later, Bhaskara, he was also a genius in the field of mathematics and astronomy. He actually, if you think he is like it's time scale of 1,000 years back from now, he first time calculated the length of the sidereal year, which means the time taken by Earth for a one complete rotation, which is basically 365.2588 days. Okay, the modern accepted value is 365.25636 days, which is basically just 3.5 minutes in a difference. So you can think of like 1,000 years back without any instrument, without any telescopes, anything. I mean, you cannot think of anything. Then he actually found out the value of the sidereal time or the time for 1 year in Earth, and it's pretty accurate of the 3.5 minutes. Okay. So there are lots of other contributors like Bhaskara Vance, Barahamira. I mean, they have contributed. These two just are like the honorable mention among them. Later, Copernicus, you might heard of him. He was a Polish doctor, lawyer, and also an amateur astronomer. So he first, using his astronomical instruments, he first find out the simple model like heliocentric or sun-centered. So first time he said, okay, what Ptolemy says like Earth is a center, but he says, okay, from his own calculation, it seems that our solar system is sun-centered or called heliocentric rather than the Earth-centered. But he published his idea during his deathbed, but it's because of the lack of evidence it was not accepted. Later, Galileo was the first major contributor to the field of astronomy, and you will be surprised. Actually, he did not invent the telescope. The telescope is invented or patented by Hans Lippershey, which is a Dutch lens maker in 1608. Then Galileo used it for the astronomy. He discovered the moons of Jupiter, observed the imperfections of the surface of the moon. Then he also discovered that the sun rotates also on an axis by observing the sunspot which is moving around it. But he was convicted for heresy. Heresy means he was actually proposing some idea which are against the ideas proposed by the Orthodox Catholic churches. So he was under house arrest and he died. But you will be surprised, his convictions was overturned in the year 1992, almost 300 years after his proposed idea. So just recently, Pope John Paul II says that, okay, Galileo was right. Anyway, so you can see like astronomers all over like the time from like before Christ and after this, so they have to have very hard time to actually put forward the truth behind our solar system and how we are actually structured in the entire universe. But we did, the astronomers make effort to do so. Then you all heard about Albert Einstein. He actually proposed to general theory of relativity and special relativity, like basically the space-time, which the shape of the space-time can be influenced by the presence of matter, and matter energy can be and having a simple relationship. Also, the special theory deals with the behavior of light in a Plassard space-time, and the light speed is maximum 300,000 kilometers per second. So these are the two most important. I mean, one of very important postulates that have been put forward by Albert Einstein, and then people are still, I mean, we are still working on to understand the full details of these theories, and then finding out evidences, having much better observation, improved with improved instruments. Carl Sagan, probably you might heard of him, but he was an American astronomer, cosmologist, astrophysics, and also a very science communicator, a very good speaker and writer also. So here are a few books I have actually mentioned. So these are very, very motivating books for the young generation students. The Cosmos, Pale Blue Dot, and then Science as a Candle in the Dark. So he also write against the superstitious beliefs that actually hindered general people from understanding the science background of different events and the things happening around them. And also Contact, which also talks about the extrasolar planets and their discoveries, all these things. Okay, so I would suggest young generation to talk to read about these books, and it would be really, really interesting. I mean, you get interest to what happened in the field of astronomy. And then in India, the father of the observational astronomy, you can call Venu Bapu. You can remember him. He was actually bringing lots of astronomical research and institutes in India. One including the Venu Bapu Observatory in Tamil Nadu. He established in 1968, and it was a huge telescope, 93-inch diameter. He was the first president of International Astronomical Union, and then he discovered what is called the Wilson-Bapu effect, along with Dr. Professor C. Wilson. Basically, that's a relation between the radiation flux of the stars and the width of the emission line from the stellar atmosphere. So he is like forefather of astronomy in India. And one more, I mean, there are several other astronomers who actually helped to develop the community also. But one more honorable mention, Professor Govind Swarup. He died recently, but he actually patented, he had one of the biggest, I mean, contributions in the field of radio astronomy in India, and also not India, also all over the world. He actually patented one important technological development in the telescope, field of telescope, or the radio telescope, called the mesh technology, which you can see in this particular picture. So it's a one giant telescope made with meshes. You can see this is one mesh-like structure made with like a net-like structure. Okay, so these are meshes, and he patented this technology. Before this technology, it was a single dish shape telescope, which means one solid disk instead of a mesh. Because of the solid disk, this is the size of a 45 meter. A 45 meter disk is much heavier than a mesh-like structure, and that's why this mesh is very important. But actually, when he discovered this or patented this technology, he was offered like a few $millions by the Japanese government from JAXA actually to sell this technology patent to them. But instead, I mean, he could have sold it and he could be a very rich person by this time, but India would never be able to make such telescope. Instead of selling that, he actually developed what he called a giant meter of radio telescope, which is now in Pune, which is consist of 30 of similar type of telescope, and it is actually contributing and discovering lots of things around the universe. All of the scientists, not only from India, also from the world, they actually recognize such major facility in the world, and they actually using them for their own research purpose. Okay. So he was a patriot, and he actually have very major contributions in the field of radio astronomy. Okay, he will always be remembered for his discovery and the contribution. So apart from these two scientists, there are also other scientists who have contributed. And so if you just keep on talking about them. It will be just cannot be finished in 1 hour, but we are actually having a very big community in the field of astronomy and astrophysics. An honorable mention, Stephen Hawking. He was a theoretical physicist, and he was also a Lucasian professor in the mathematics at the Cambridge University. This position was held by Isaac Newton before Stephen Hawking. He actually discovered the theoretical background of black holes and the Big Bang. He proposed Big Bang, and then the Big Bang, which we are now people are now trying to observe, trying to find out the evidences of Big Bangs and black holes through different observations. And he also a forefather of the string theory. So basically, these are the scientists from 500 years BC to until now. Some of the scientists, actually, to be honest, who actually greatly contributed to the field of astronomy and their development. And you can see like how the scientists have to struggle through in different times to prove their concepts and the ideas. Stephen Hawking, when he actually proposed his idea, we don't have actually any such technology to actually find out the things, the proposal, the theories he has proposed. And then with the technical advancement also, the same goes with the Albert Einstein. But now we are actually making large, for example, the gravitational wave detector is one of them, which are giving him the direct evidence that the space-time have curve and giving the direct proof of Einstein general relativity. So we are both in the theoretical direction as well as the observation side, we are making progress. Okay, let's now come to the Earth's cosmic address. So where are we, for example? Earth is the third planet, okay, in the interstellar system from the Sun. But Sun is one of the 100 billion stars in our system, in the Milky Way. And the Milky Way is one of the 40 galaxies in the local group. And the local group is a part of local supercluster called Virgo, which is the part of the universe. So now you can think of how tiny we are. So here is a pictorial presentation where we show the Earth here as a part of the solar system, and this entire solar system can fit in like a one tiny dot in the Milky Way galaxy. This is a picture of galaxy. The Milky Way galaxy is a part of local group, as I told. So it's a 40 such galaxies, and then one tiny dot is one local group, and these are all called the part of 40 called the local supercluster. And this small supercluster is one tiny dot in the entire universe. Okay, so basically, going from the Earth to the universe, you can actually be amazed how tiny and how small we are compared to the entire universe. And talking about our own home Milky Way galaxy, it's a spiral galaxy, which you can see in the left-hand panel, and our Sun is one of the several billion stars in this Milky Way galaxy. This is a side view, and this is the top view of our Milky Way or the spiral galaxy. So where are we in this galaxy? This is the center of the galaxy, and our Sun or the solar system is somewhere here, which is basically 40,000 parsec. So 1 parsec is 3.26 light years, and light year is defined as the distance light traveled in time scale of 1 year. The size of our galaxy is 100,000 light years. Okay, so this central galaxy is a nucleus and also the central bulge, and you can see them like a whole little galaxy. Who is our neighbor? Our closest neighbor is Andromeda Galaxy, and this is more like a Milky Way galaxy, and it is 2.2 million light years away. Okay, and it is approaching us at a speed of 6.67 million or 6.7 lakhs miles an hour. Okay, so basically you might heard that, some of you might know that the universe is expanding, which means some of the galaxies is moving towards us and some is receding from us. Andromeda is one which is moving towards us, and from few billions of years time scale from now, the Andromeda is going to collide with our Milky Way galaxy. Okay, so that is a very, very long time scale. You don't need to worry about it, but this is how the universe is behaving, okay, on how the galaxies inside the universe are moving. Andromeda Galaxy is one galaxy which we can see through our telescope. It's very nearby and it's although very faint, but we can make it out using our own telescope. So we'll try that now. So what we did, there are one terminology called the amateur astronomy. So amateur astronomy is just called the backyard astronomy, it's just for fun. So it's not just like having your own telescope, go to backyard, go to find a very distant and dark place, or go to the top of the mountain and look at the sky. That's what for astronomy, amateur astronomy. And then, but not only just like a plethora of objects you can find on the sky, you can actually find lots of scientific research you can actually contribute to them. Basically, since there are, as I told you, billions of stars around us, and we don't know all of them, we know just a fraction of them. So that means there are lots of opportunity or potential actually to make the discovery, even if you have a very small telescope. It doesn't matter really how big is it. If you have a big telescope, you can resolve the things, but if you don't have, then it's still okay. You can still discover, like you can track asteroids, you can look at the variable stars, you can look at the bright objects like comets or the transient objects. Okay, so this is all are part of the amateur astronomy. And the equipment we use, like binoculars, telescopes, and photography. Okay, binoculars are very small. You probably have used. You have some of you have seen the telescopes also. So once we organize some events, you can come here and have a look at it. While coming, and the photography we used to do nowadays with our own mobile cameras and all these things. So just while come to this particular things about the telescope, I'll try to briefly say for the students particularly what this telescope. There are two different types of telescope that we're using. One is called the reflecting type telescope, which means you have two mirrors. One is here and one is here. This is called the primary mirror and this is secondary mirror. The light from the outer sky, they come, have a reflection and goes back to secondary mirror, and through the lens it comes to your eyes. Okay, that is one kind of telescope called the Newtonian reflecting telescope. Okay, there is another type of telescope called the refracting telescope, which means there is a refraction through multiple lenses, and you can directly look at the object through the other end of the telescope. Okay. Now the difference is this telescope cannot be made bigger because of the lots of objects and components. Okay, so that means it has very small size aperture, so we can only see a very small patch of sky, and also your light gathering power would be less compared to the reflecting telescope. But another important difference, the problem with the refracting telescope is what is called the chromatic aberrance. A chromatic aberrations means if you look at, for example, the moon, you can see colored ring around different at the edges. Okay, so you can see here there are red and green colors. Also, if you look at the Jupiter here through a refracting telescope, you can see color patches here. So these are the one drawback which comes with the refraction in the refractive telescope, but reflections don't have this drawback. So you can use reflecting telescope to look at them. Also, you can make the reflecting telescope as big possible. So actually, we purchased this 14-inch reflecting Newtonian reflecting telescope, which works on this particular principle. Okay. But before telescope, there are things like called the armillary spheres. So this is geocentric. So which means the Earth is at the center, and they develop a model, okay, a toy model where how the different stars and the celestial objects rotate around Earth as a center, and also the sun. Not only that, you have astrolabe. Astrolabe is basically you can measure the elevations of any star with respect to the horizon. Then you can know what is the date and time from the scales giving the astrolabe. Also, people use the sundial. Okay. So these are very primitive kind of instrument people have used so far, and they concluded that, I mean, using this kind of instrument, you can think of people concluded that the Earth is not the center of our solar system, actually it's the sun. So that's why we actually ask, as I told you, we had many big questions. For example, is the Earth the center of the universe? How far are the stars? What are they made of? Is the solar system the center of galaxy? Are there more than one galaxies? All these questions are very, very relevant to our basic fundamental existence on this or the support of life on Earth. Okay. So, for example, I'll give you some example like how do we actually approach to answer these questions, big questions. So, for example, using the telescope. So, Aristotle believes that Earth is at the center and all other planets are moving around it. But what we found, like Sun is a fixed, and then others are rotating around it. But this is also comes from Galileo when he observed Venus using his small telescope. Okay, so he actually find out that the Venus have a phases. So like Earth shadow on Moon, Venus can have a shadow, and then phase of the Venus actually changing as it rotates around. So if if our center, so if it is Earth center, then Venus phase should not have changed. But if it is Sun center, then the Venus, if it goes the beyond or the behind the Sun, it actually casts shadow on the Venus, and then you can see the shadows changes. So from this particular observation, the change in the shadow of the Venus, Galileo concluded that our system, our solar system is not Earth centered, it's the Sun centered. Okay, but all this comes from what they have found in the telescope. Then how far are these stars away? Okay, so we in the night sky we see different stars having different colors, having different brightness, but are they the same? All the bright stars are nearby, or the faint stars are far away? It might not be true. So, so first time, like long back in 1838, Frederick William Bessel, he first proposed the idea of measuring the distance of stars using the fact that the background stars are fixed, with what we call the parallax method. What is parallax method? So, for example, here is the Earth, here here is the Sun, here is the Earth. So, Earth is rotating around the Sun. So, in 6 months, we are exactly in the opposite side of the Earth where it was initially. So, which means if you want to look at the star here, 6 months back you will see the star somewhere here, and then after 6 months it will be having some angle with respect to the previous position. So there will be an angular deviation here. And then if you look, this is the diagram he proposed, like the parallax method he used, and then he calculated distance to some of the stars. If you know this angle, if you know the distance to the Earth and Sun, then you can actually calculate the distance to this particular star. And then this is the actual measurements he did. So here you can see there is one star here, and the two small stars very close by. And then after 6 months, you can see these two stars here. The position changes, but if you look carefully, the star behind that moves slightly further away compared to the star in front of it. So just by looking in these two particular stars, you can find out like how much the star have moved with respect to the front star, and then in how many time scale or how many months it happened. So then you can actually find out what is the parallax or what is the distance to the star which is far away, okay, or which is here. So this is the idea. But the idea also based on like all the background stars which are very, very far away, they don't move over the small time scale of 6 months or so. So in this particular diagram, all these background stars, they are relatively fixed in their position. So you can see this star, they don't change their position in 6 months time scale. But these two stars, they do change their position, so because they are nearby. Okay, so this is a very important discovery of a technique to measure the distance of a star back in like 200 years back. Then the question is, what are the stars made of? People ask. So we can see here as the Orion Nebula, and you can see the bright stars. They are the newborn stars, and you can see them in the naked sky. If you look at the Orion Nebula, near the belt of the nebula, you can see this particular stars. The question is, the same question have been asked also a long time back, like 200 years back, and then people see the rainbow, for example. The rainbow is basically the light reflections from the sun, and then if you study the rainbow using a spectrum, then you can see there are different colors, and there are several absorptions line also. So Fraunhofer, first time he discovered that the rainbow, actually the sun, the actual light coming from the sun. He discovered what he called the spectrum, but later, then the light from the sun also been studied, by Kirchhoff's and Bunsen, and they found the sun solar spectra is also made of different lines. So the black one we call the absorption line, which means those emissions line, they have been absorbed by the outer atmosphere, and this is the actual spectrum, that is emission spectrum. Okay, so from this particular discovery, okay, sorry. Just one second. Yeah. Yeah. So from this particular discovery, actually, yeah, they have found that the stars are other suns. Okay. So basically, they found the spectrum from the star the same way they have found the spectrum from the sun. They do compare, and they concluded that other stuff on the star on the sky, they have seen truth, and they are very similar to what we see like a sun. Okay. Then another question, like, where is the sun in our galaxy? Is it at the center or somewhere else? So these are the questions people have asked over ages, over a long time scale, and people using different techniques, they are trying to find out the answers. So, for example, Harlow Shapley and Henrietta Leavitt, using a 60-inch reflecting telescope from the Mount Wilson, they have found out there are globular clusters, okay, which is called the M13, which is a cluster of stars, small, very old stars. Okay, so which means there are stars in our galaxies, which means our solar system is not like an individual object. It must be part of some big star cluster, and because of the part, we can see other star clusters, which is called the globular cluster. And they first time proposed that we are a part of a even bigger structure, which we call the Milky Way. And they first time find out the location of the sun and the center of the Milky Way galaxy. So sun is somewhere located far away from this center. Okay, so using their 16 reflecting telescope, they actually find out that we are not the like individual entity. Solar system is not an individual entity. It is a part of a bigger system, and they found it from the study of the globular cluster, and they found few more clusters around here, and they said, okay, we must be a part of a galaxy or some structure which is made of such clusters, small star clusters, and they ultimately discovered with their telescope the galaxy, the Milky Way galaxy, and our positions in the galaxy. So this is we are the only one galaxy, or are there many galaxies? Okay, so now we know there are many galaxies, but it was not an easy question to answer hundreds of years back. So this is, for example, M81. These are the colliding galaxies. You can see two galaxies are in collision. These are all the images which are taken by Hubble Space Telescope. Okay, but back then, long time back, Edwin Hubble, using the 100-inch reflecting telescope Mount Wilson, he found that there are stars which are called the Cepheid variables, which means they are pulsating stars, and their pulsation period changes with the time, and they are changing with the time. And then if you calculate the time and the distance, there is a relationship called the Hubble's law. And from their law, he found out, okay, we have stars which are very, very far away from compared to the size of our own galaxy, which means there are things which are outside our galaxy. That is the first very important discovery by Edwin Hubble, and also one giant step towards our understanding something. There is a universe, there is a world outside our own galaxy. So he discovered many other galaxies, like including the Andromeda and other far away galaxies. And then we have started working on which is called the nebula distance. And then we finally revealed there is a universe which is full of galaxies using the Hubble Deep Field image. So all you can see in this image, this red, they are all galaxies like our own Milky Way galaxy, and they are very, very, very far away. So this is what we are universe made of. Okay, so then the question, how did this begin basically? So if it is exists now, what happened long time back ago? So everything, how did it started? What did to come from? So Robert Wilson and Arnold using a microwave receiver, he first time calculated, they first time proposed that if there is a Big Bang, there is some starting of our universe, then there must have some signal which actually originates then we can still detect it. So one might be this microwaves. So using the microwave receiver, they found some signals which called the microwave background radiation, and they discovered it. This radiation must be related to the what we call the Big Bang. Basically, if you remember, we had the television sets old time back, and when you turn it on, this television set, you can see very noisy pattern when there is no channels. So some of these noises actually contributed, a fraction of them caused by the cosmic microwave background, which is we call the remnant of a Big Bang, the start of our universe. Okay, so because of this discovery, they have received the Nobel Prize because this is one direct evidence that our universe start with the Big Bang, or basically some kind of massive explosion. Okay, and then Hubble Space Telescope and other telescopes, they actually use data to find out what is the time, I mean, how long back actually things started. So they found it's typically 13.7 billion years back when this Big Bang occurs. Okay. Okay, so and also the final questions like, are there any other planets like us? So are there like similar to our solar system, like our Earth Sun system? Are there any other? So Herschel, using a very large telescope in 1781, he discovered Uranus. So Uranus is basically now you know a planet where during his time, I mean, you can think of almost 300 years back, 250 years back, we can only see until Saturn, so nothing can be observed. So using his large telescope, he first time observed Uranus, and he thought like it's an some planets which are similar. It's a planet, and then probably it might host something similar to our own Earth. But now we know there are all extrasolar planets that discovered. The new missions called the Kepler space missions, it has discovered several new exosolar planets. Okay, Kepler 22b, Kepler 69c, all these are planets. And this picture here, these new discoveries with respect to Earth, the size is relative to the Earth and their distance. So it is possible that some of these planets might harbor Earth, might harbor life on its surface, but we really don't know. So lots of research going on with the Kepler data, also from the ground-based telescopes, and probably one day we are going to see them. We are going to find them out there. But the question is, how do we discover this particular extrasolar planet? So there are several methods. One method I am showing here. Here you can see when the planet, let's say this is Sun and this is our one other planet like Earth. When the planet moves in front of that particular star, there is a dip in the particular brightness because some portion of the star is blocked by the planet and the brightness drops here. And as soon as the planet moves out of the star, you can see it going out, the brightness goes up. So from looking at this particular profile, the structure of the profile, the length of the dip, and the amount of depression, we can actually find out the size of the planet, how far away from the star, and then we can predict whether it's possible to actually to host a life on this particular planet. So this is one technique called the photometric transit method, but there are several other techniques people are employing. Okay. So this is a very vast, new and hot field called the extrasolar planets, or exoplanet, and it's now growing up with all new missions like the JWST, which is coming up quickly. But as I told you, all these things we have did so far using the telescope from the ground-based observatories. Okay, but this ground-based telescope has a disadvantage. What? We have atmosphere in between. Okay, so which means if you look at the sun, for example, if you look at the setting sun in a seafront, you can see the edge of the sun are not very sharp. It has very distortion, and you know this distortion is caused by the atmospheric turbulences. Okay, so that means the turbulences actually cause the distortion to our view, and we cannot actually avoid them. Okay, it will always be there. Here is a comparison. One is taken by the space-based telescope and one is taken by the ground-based telescope. You can see the space-based telescope can actually resolve lots of stars, but it cannot be done with the ground-based. So turbulence are causing the distortion in the image, and we are trying to improve them. But then the question, what actually causing the twinkling of a star, which is a fundamental question for all astronomers. Here is a representation of what causes. You have a star out there. You are seeing through a telescope here. You have an atmosphere here, which is changing with the temperature of the atmosphere changing constantly. And because of the change in the temperature, the refraction through the atmosphere changes, refractive index changes, and you can see multiple image of the star in different times. So in every second, this is all the dots which is shown in the right hand side is basically coming from one star only. And because of the distortion, you see multiple images. And if you accumulate such 10 seconds or 100 seconds of many images, 10 images together, you can see one very faint or expanded dot, which is shown here in this particular diagram. Okay. So this is the one main problem with the ground-based observatory. But if you keep this particular telescope at the top of the mountain, so you have a less atmosphere there, then this kind of problem can be get rid of. So that's why many of the, you can think of many of the telescope are kept on the high altitude in the mountain. Okay. So the solution to this problem, okay, send the spacecraft into the sky. Okay, that is one simple, but it's very, very critical and very difficult stuff, because when you send it to the sky, then it would be very difficult to do any kind of maintenance or repairing to this particular spacecraft once it's launched into the sky. Okay, so here is a one small video. Okay. Okay, so actually launch, briefly speaking, how we launch a satellite into the space and how we go further away into the different planets. And then probably in the upcoming lectures, there will be many experts from the field, how do they do launch satellites into the space and how to probe them. But then once you are in the space, once you have your satellite, your instrument ready, you can have a view like this, which you can never be attained from any ground-based telescopes. Okay, so you can see this is the structure of a particular bulge-like shape, a galaxy, and they are in the multicolored. So different color represents different wavelengths, and all these small fraction are the background galaxies, and there are lots of several bright stars in, you can see in this particular. So you can see the arm of this particular galaxy, and they made of bright star, young stars. Okay, so inner part, this red line, this is infrared emissions which are coming from very old hot stuff. Okay, so this galaxy, I mean the picture of this galaxy tells billions, gives a millions of information about the structure of the galaxy, its motions, and then what are the contents of the galaxies, and how the distributions of matter in the galaxy. Okay. So for example, here is the aurora that we have observed in the Jupiter's North Pole. But these aurora are mostly observable in ultraviolet. So, but we don't see ultraviolet X-rays or high energy particles. So this is a false color image. So if the aurora can be viewed through the optical, then or green light, how it looks like. So it's a presentation, but this is a real picture of the aurora seen in the polar cap of Jupiter. Okay, so this is caused by the strong particles moving on the field lines of fields of magnetic lines in the pole of the Jupiter, and this also gives us lots of information about the polar structure of the Jupiter. So the polar structure, basically we had the Jupiter has a strong magnetic field. They do have the charged particle which are moving around on the top of the poles, and those charged particle interact, and during the motions they are having with a fluorescence light coming up from the gas, and then these are probably acceleration and deceleration of the charges which causing particular ultraviolet light. So this ultraviolet light cannot be observed by any ultraviolet telescope from the ground, because our Earth's atmosphere actually absorbs the ultraviolet coming out from there. So here is a image of one of the moon of Jupiter named Io, and this image is taken by the Hubble Space Telescope. But you can see this is a very blurred image. Although it's blurred, but you need to think of it billions of miles away from here. So considering the distance to this particular moon, it actually is very impressive. But if we can send a spacecraft close to Io, actually what we see here called the plumes. So there are volcanic activities, and due to the volcanic activities, the plumes of gases and other materials coming up from the surface of Io. So this is basically possible to see the detect due to the Juno mission. Okay, it's a Jupiter mission, and once Juno are very close to Jupiter, one of this picture have been captured. So which means the surface, and also the Io is very active under the surface, and then lots of volcanic eruptions and things are going on, which means that there are possibilities that this dynamic was actually very long time back. It was a very important place, probably harboring life, because the dynamics is still very active. So these are the images of Mars taken using Mangalyaan. So you can see the surface of Mars, the pole of Mars having this polar cap having ice constellations, and then the red color on the surface, the red color due to lots of ions and other methane which is deposited here, and you can see lots of craters. The craters, as I told you, like the similar to Moon's crater, which is being created by the impact of meteorite on the surface. But the one important thing, even if you go closer, you can take further image. Here you can see that the dry river bed on the Mars. Close look with some very high resolution instrument, then this is a river bed. So on the Mars, and it was like millions of years back. There is a river flowing through this particular channel, and it was left over like a one. So it means that millions of years back, due to this ice cap and the riverbed, it tells that Mars was once might be harboring water on the surface, and water means there is a chance of having some form of life. There was chances, and it's not still the end of the story. People are still trying to find out whether Mars can still hold the potential clues for the harboring life in that planet. Okay. So, and this is the again Voyager missions in 1981. It was sent to the to actually explore the ring, Saturn's ring, and you can see very high resolution rings of individual rings of Saturn, and it consists of small and large particles around it. Okay, so you can see very detailed structure of the Saturn's ring, which none of which actually can be viewed from any ground-based observatory. Okay, so far existed. So it was launched in 1981 at a distance, and it traveled a distance of 2.5 million miles. And you can see the dusty feature which can stretch up to the screen, and it's almost 12,400 miles in length. Okay. But then it's the old one. Now we have a Cassini-Huygens missions where we can see the Saturn's ring in a great detail. You can see each and individual rings, I mean different colors. Different colors are basically contents of the rings and the chemical contents of the rings, and also represent the structure of the ring. So density of the rings. The rings are denser at the middle and they are less dense at the end. So these information can only be seen or observed through some missions which are space-based, which when you can send a spacecraft to the onto the space and then able to reach to the surface of the planet, close to the planet. So that means telescopes, either it's a space-based or a ground-based, is actually change our perspective towards the universe, and then it helps us to better understand the universe and what is our position in the entire universe and how things have changed, how to have evolved. So we always need telescopes to understand them, okay, from time to time, and then answering some of these big questions and changing our understanding of the places in the universe, like from the center of the universe, okay, and how small, pretty small we are when we look at the bigger picture, like the clusters level as we described. So we are very tiny here, but we are the only species we know so far. We can actually understand and comprehend the process of the universe much better than anything else in the universe exists so far. So more we learn and more questions emerge and more we grow. Like for example, what beyond the Pluto in our solar system? So for example, are there any exosolar planets which can harbor life? We are now searching them. How the stars and the planets form? Any evidence which can we relate? We have actually talked some of them. Why there are black holes in the center of the galaxies and how do they exist? I mean, how do they ever come to exist and what are their futures? How did galaxy form? Why the space is expanding? All these questions we always ask, and then we are trying to answer in the journey of astronomy. And the telescope will continue to expand. For example, this is Chandra. These are the 5 best telescopes in the world. Although Arecibo is now down, it's broken down. It's very old one, but the largest one now it has been replaced with another radio telescope from China, which is 500-meter large. But apart from that, Chandra X-ray telescope, Spitzer, Keck, ground-based telescope, and Keck telescope, and also here the C4 system class telescope. They all actually helping us together to reveal the mysteries of the universe in different wavelengths. Chandra in X-ray, Spitzer in infrared, and the Keck in the optical. So all different bands, they are giving different information. Then we are trying to understand the universe as much as possible. But not only the international, we also have telescopes in India, which we are making a strong contributions towards the understanding of the astronomy. For example, here are a few examples. One is the Aries in Nainital. It has 1-meter telescope. This is one of the largest telescope, 2-meter telescope known as the Himalayan Chandra telescope. It's placed in the Ladakh, Kashmir. This is the radio telescope in GMRT, as we talked about, one of the largest radio telescope in India and the second largest in the world in a mesh type. This is the Venu Bapu telescope in in Tamil Nadu, and this is the Mount Abu telescope in Rajasthan. This is the infrared telescope. This is one of the large optical telescopes. This is an optical telescope in Pune, Khorat. This is operated by Mayukh, and this is also 2-meter class telescope. So these are big facilities in India, which combining and contributing together to understand of the astronomy, astrophysics, and the things going on in the sky. And you can be a part of these telescope projects. You can go have a visit to them, and you can understand how these telescopes work and what are the research they are doing with these telescopes. So this is all from my side, and then please join as a member to our group. So we are trying to grow as a group, and this is a journey you'll always cherish, and you'll always be happy to share with your kids, with your young generation. As you engage and you grow, as you participate, you do things, and you learn more about our own existence in the universe. Okay, thank you very much.
Sir, could we please ask some questions?
Do you have anyone of any question?
Yes, sir, I have questions. Please go that slide where you put, if it's true, there are some aliens.
Sorry, can you
Yes.
repeat which slide you are talking about?
Yeah, there is a slide where you write, if it's true, there are some aliens. It's quite interesting to look.
Sorry, I cannot hear you clearly. Can you just repeat?
Sir, you wrote a slide that text that if it's true, there are some aliens. So could you go please that site, some rock site?
So it's like a Mars.
Yes, yes.
Okay, okay. Just. This is the thing about.
No, sir. In the starting, I think 10th, 11th slides.
Okay, okay, just let me know. In the starting, you're saying.
Yeah,
So here somewhere or before that?
before that.
Okay.
Title was like that. If it's
This.
yeah, 16 slide. Yeah, yeah. So I didn't get the point why you wrote it. This is true. Like there are some rock parts. There is some element abundance. So could you please explore more that?
This one you are talking about?
Yes, sir.
Okay, okay. So basically, this is the meteorite that we obtained in 1980s around in Australia. So this part of material, when the chemists take into the lab and they do what this meteorite contains, they are very surprised. They found amino acids. Amino acids are basically building blocks of all life on Earth. Okay, and it's contained in 7 to 60 parts per millimeter. So which means it's a very low fraction, but it's very significant that it's present here in the meteorite, which means this means that this meteorite is coming from somewhere in the outer space, and from there it actually taking the amino acids inside it. So that means these amino acids, which are basic building blocks for life, were there somewhere in the space, and it actually tells us that okay, it might be possible that this meteorite gives us a message that okay, it is coming. It is possible that we are also uh, having a born or origin of outer space. Okay, because this is one of the very important discoveries there. So you can just ignore this particular chemical composition. These are the chemical composition that found in these meteors, and these are all different things. Okay, so if you just go and search for this Murchison meteorite, then you can get the details about it. And it's very, very, one of the most fascinating discovery in astronomy. Like we got meteorites which contain amino acids, and which gives us a direct evidence like, yeah, it's possible that we are coming from the outer world. Our origin is not here. So an alternative theory tells that, okay, you can actually form amino acid in a different conditions, like you have lots of carbons in the air, you have lots of lightning strike, we actually making these molecules, and those molecules form again with some suitable environment amino acids. So there are theories which tells that no, it's not from the outside earth. It is possible that on suitable conditions, amino acid can be formed in earth, okay, from the basic building blocks, molecules, elements like carbon, hydrogen, oxygen, all these things. But that is one theory, but this is an alternative theory. No, it's all landed from somewhere outside our Earth, maybe outside our solar system. We don't know from where it came. Okay, but this is a piece of evidence that is very, very compelling that, yeah, it's possible that we came from, or our building blocks came from the outside Earth.
So it's basically outside from that our galaxy or that outer space.
Yes, yes, that is true. Yeah.
Okay, thank you, sir.
Okay. Any other questions from anyone?
Sir, some student raised the hand, so could you please check?
Johan Sharma, yeah. Hello, Johan. Can you unmute and ask your question?
Yes, sir. First of all, thank you for this wonderful talk, sir. I wanted to ask that many times we hear that scientists have found some new planet that have water or carbon or other things on it, like the planet outside the solar system. So I wanted to ask that how these planets are observed. Like we observe the star with the telescope, but how do we observe these things on extraterrestrial planets?
Okay, so in my talk, I actually talked about one such method we call is the transit method. So here I'll show you once again. Yeah, so in this method, so there are several methods we can try to do that. Okay, so one method is what we call the transit method. Here the planet is passing in front of the star, and when it is in front of the star, some fraction of the star's light is blocked by the planet. And if you plot the brightness as a function of time in the bottom panel, you can see that the brightness drops as the planet moves in front of the star, and as it moves out of the star's way, then the brightness regains. So from by studying the amount of drop, the size of this particular dip, and at what time, the repetition of this block, we can actually calculate find out the periodicity of this particular planet around the sun, around that particular star, the distance from the star, and the size of the planet. Okay, so from that we can actually guess if a planet of this size having far away like a star like sun is kept, what would be the chances that there would be water or carbon or like this. Okay, so we already had the data, like for example, if a planet is placed, let's say, at a distance from 1 earth, 2 earth, or 1.5 earth, what are the chances that there will be a life formations or water or other one. So this one method actually can tell you what is the distance and what is the structure of that particular star and planetary system. Then you can actually predict if there is any. That is one thing, but that is on the prediction basis. Another is to directly take the spectra coming from the planet. Okay, so from the spectral lines, you can actually find out, for example, the water, the CO2, the other molecules, they have their own individual signature on the spectra. So you look for the signature from the spectra taken, and then you try to find out or decode like what are the molecules present on the atmosphere of that planet. Okay, so that is another method. But most of the time, the planets are so faint that actually having a spectra, taking a spectra would be very, very difficult. So from the discovery point of view, and from the point of view of the orbit around of the planet or the size of the planet around that particular star, this transit method is one of the most famous method and more reliable method of discovering new exoplanets. But if you really want to know whether I say what are alcohol or amino acid content, you really need to look at the spectra that is getting from the radiation of that planet. Is that okay?
Yeah, thank you, sir.